Hi guys, welcome back. So I've got a little bit more of a complex example for you. I actually think this could probably still fall within the realm of simple familiar, but we'll start off with a relatively simple one and we'll build our way up. So just as a refresh, when we have a problem like this, we're always going to let the inside function be equal to u. We're going to find the derivative of x with respect to u. And then we're going to rearrange so we can substitute dx into this equation. Oh, I put those values the wrong way around. Hold on. There we go. Okay, so let's keep going. So du over 2x is going to be equal to dx. So we can substitute these values in now. So we have x times by u to the power of 5 over 2 multiplied by 1 over 2x du. Okay, so these are now going to simplify, and that's just going to simplify to 1 over 2. And all we need to do now is find the integral of u to the power of 5 over 2 du. So we're going to raise this to the power of 1. So this is going to become 7 over 2, and then we're going to divide by the new power. So dividing by 7 over 2 is the same as timesing by 2 over 7. So this is going to become 2 u to the power of 7 over 2 over 7 plus c. And finishing this multiplication off now, this is going to become, let's write our function at the same time, x squared plus 1 to the power of 7 over 2 times by 2 over 14 plus c, and again let's just simplify this. So this is going to be 1/7 now, so x squared plus 1 to the power of 7 over 2 over 14 plus c. Okay, so I think that was a little bit of a simple familiar example, but it's a good, little bit more complicated one than the last examples to jump into these complex familiar questions. Okay, again, I might just use some colors here just to sort of help to illustrate what I'm doing. So the first thing that I am going to do is I'm always going to let the inside function equal to u. If you don't know what I mean by the inside function, by the way, I generally mean the function within the brackets. So the smallest level of brackets that you can get to. And the reason that I could say that this is the lowest level of brackets is because really this is 2x plus 3 times by sine x squared plus 3x minus 2. And so the innermost set of brackets is going to be this function here attached to the sine. So that's just my little tip for picking inside functions. So we're going to let u equal to x squared plus 3x minus 2. And then we're going to find the derivative of that function with respect to u. Okay, so now what we're going to do is we are going to rearrange so that I have dx is equal to something, and I can substitute that back into this part here. So again, we might just do this in a different color so you can see. And so du over 2x plus 3 is going to be equal to dx. So I can just substitute each of these values in now. Okay, I might just draw a line here so we can see. So the integral of 2x plus 3 multiplied by sine of u. So remember our u, we were doing that in our lovely blue color. And then we're going to substitute this in red, so times by du over 2x plus 3. And again, these terms are going to divide to be equal to 1, and we've now got a really simple integral to deal with. So this is going to be the integral of sine u with respect to u. By the way, when it comes to integrating sine and cos, I'm going to be honest here, as a maths teacher, I never remember the exact order. What I do is I just remember one of them and the rest of them come from that. And I always remember when you find the derivative of sine, you get cos. So this is the only piece of information that sticks in my brain ever, because everything else comes from that. So that means that the derivative of cos is going to go to negative sine. And so now that I've worked out that derivative, it's going to be easy for me to work out the integrals, because cos is going to go to sine, and then if I integrate sine, it's going to go to negative cos. And that just helps me because I literally do like maths all day, every day, and I have like essential maths and like junior maths, like, and I have all the way up to specialist maths. So I've got a lot of maths content in my brain. If I can minimize the amount of information that I have to remember, it's going to make it a lot easier for my brain to be able to teach. So that's just my little hint for you guys. If you can never remember all of them, is to just remember one, and then the rest can be derived from that one. Okay, so now I need to integrate sign, and I know that that's just going to be negative cos u plus c, and I'm going to substitute back in my value for u, which was x squared plus 3x minus 2 plus c. All right, let's just do one more of these more complex examples. Alrighty, last one. So again, I'm just going to choose this bottom function here to be equal to u. So u is equal to e to the power of x minus 1. The derivative of u with respect to x is going to be equal to e to the power of x. So what we can do is we can now substitute this value into here. I've got to find, if I rearrange this, so du over e to the power of x is going to be equal to dx, and so now I can substitute this value in as well. And so that is going to give me the integral of e to the power of 3x over u multiplied by du over e to the power of x. Okay, so I'm guessing that we're noticing a little issue here, and that is when I simplify this function, I'm not actually going to be able to get rid of this x value. So I'm going to have to be a little bit sneaky. And what I'm actually going to do is I'm going to take this function from earlier. So I might just pop that here, because if u is equal to e to the power of x minus 1, then when I rearrange this equation, I can get u minus 1 is equal to e to the power of x. Now we can see here I've got e to the power of 2x, so I must just have squared this particular function. And so now I can substitute this into this function here. Okay, so let's do that. That's going to give me the integral of u minus 1 squared over u, and derive that with respect to u. So I've expanded those brackets, and then I've simplified, and now you can see that this function is going to be so much simpler because we're just going to find the integral of each of these particular elements. So the integral of u with respect to u is going to be u to the power of 2 over 2. Integral of negative 2 is going to be negative 2u, and the integral of 1 over u is going to be ln of u plus c. Okay, so let's substitute u back into our function now. So what was our original value? Yeah, over here. E to the power of x take 1 over 2 minus 2 lots of e to the power of x take 1 plus ln of, oh gosh, I didn't give myself enough space. 1 second, we might write that down on the next line just so I can fit it. Plus ln of e to the power of x take 1. Oh, I always do that with the second bracket. Plus c. Okay, so those are some examples of some more complex substitution with integration of non-linear functions. All right, might do one more video on this with a few more, even more complex examples. So maybe moving into the complex familiar, complex unfamiliar territory. Alrighty guys, see you in the next video.